Hello and welcome to Graphing Absolute Value Equations. We're finally moving beyond lines and we're going to be graphing this new function that you've never seen before. You're going to need a pencil and maybe a calculator and then your notebook. And if you have the graphing kind of notebook, you don't need graph paper, but if you don't have the graphing kind, you need to go and get some graph paper and make sure that you have graph paper to put into your notebook. All right, so here we go. You're going to need to write down every one of these examples. So this one is graph y equals absolute value of x. So before we learned how to graph lines using the shortcuts, we would always use a table of values. That's the way we graph. The first way you learned how to graph a line is to use table of values. So we're going to go back to that. There's nothing wrong with using a table of values, and so we are going to use that idea to graph these absolute values today. And so when we did graph using a table of values, we would always look at our table of values and say, okay, let's plug in some values for x. So what kind of values for x did we plug in? Well, we usually would plug in 0, and we would plug in 1 and 2, and maybe -1 and -2. And those would be the values that we would plug back into the function and find the value of y. So we're going to do that today. We're going to take our y equals absolute value x, and we are going to substitute a -2 in there. So what is the absolute value of -2? Well, the absolute value of -2 is 2. It's positive because it's distance. Absolute value of -1, 1. Absolute value of 0, 0. Absolute value of 1, 1. Absolute value of 2 is 2. So then when you found your XY table, you would go over to your graph and you would plot these points, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Well, this doesn't look like anything that I have graphed before. This is a V. The shape is a V, not a U, like a parabola, and not a line. So it's very important that we are able to see the V shape of this graph. If we didn't see the shape of the graph, then we might only have part of the graph. So there's a couple of things that are really important, and one of the main things that is really important is what we call the vertex. The vertex is the point at which the graph turns around. And so the vertex of this graph is 0, 0. Okay, so that's really important. And so then that would be our y equals absolute value x graph. Now let's talk about domain and range. Now we've talked a little bit about domain and range in my class. And what do we remember about domain and range? Range, domain was the x values, range were the y values that we can see on our graph and talk about on our graph. So the domain, what values could we put in for the x? So if we look at all these values, it looks like I could plug in a -2, I could plug in a -1, I could plug a 0 in, a 1 in, a 2 in, but I could also plug in a -9, I could also plug in a -200, so it really didn't matter what values I plugged in. I could plug in any value for x and I would get an output. I would get a value for y. So the domain, if you remember how we set that up with lines, was x such that x equals all real numbers. Remember, that's just a fancy way of saying all real numbers. Okay, and then the range. What about the range? Well, the range is a little bit different than it is for lines. If you remember, for lines, it was all reals for domain and range. This one's a little bit different. Look at this graph, and do you see anything down here that is being graphed? No, there is no graph down here. So where does your graph start? Well, your graph starts right there at 0, and it continues to go up and up and up forever. And so the range for this function would be y such that y is greater than or equal to 0. You could also look at your table and you can see that it goes from 2 to 1, back to 0, then back up to 1, then back up to 2. So all my values, nothing was less than 0. So everything greater than or equal to 0 would be the range of this graph. All right, so the big idea here is that we're going to get V-shaped graphs, absolute value, V for value. All right, let's do another one. Okay, example number 2, graph y equals absolute value x plus 3 is less than 4. Okay, caution. It's really important that when we graph absolute value graphs, that we don't just pick any values. We were able to on the last one. That worked out just fine. But once the graph starts having different numbers placed in within the absolute value and outside the absolute value, excuse me, we cannot just pick any values we want. Because if we pick this values, we might only see that part of the graph. Does that show a V shape? So you might miss all the other values that give the graph the V shape. All right, so you would only see this amount if you picked 3 and above. So you have to really be careful. So what I'm cautioning you on here is that we aren't going to just pick any values we want. We need to pick where we start at the vertex. And we're going to put the vertex in the middle of our table, always, so that we can see both sides of the graph. So how we do that is we take the expression out of the absolute value and we find out where it's equal to 0. That is where the x value will be the vertex, the x value of the vertex. So subtract 3, x equals negative 3. So negative 3 is the x value of my vertex. Now that I know the x value of the vertex that I want to use, I can use any values above and below that negative 3. So I might need to use negative 5 and negative 4. I might use negative 2 and negative 1. Okay? And so then once I have, remember this is the vertex. Okay, once I have that x value of the vertex and all the other values that I can plug in, then I am going to go ahead and substitute all those x values in back into the original equation. This is the original function way up here, and get some values. So let's do that. Y equals absolute value negative 1 plus 3 subtract 4. Negative 1 plus 3 is 2. The absolute value of 2 is 2. And 2 minus 4 is negative 2. Okay, let's do it again. Negative 2 plus 3 minus 4. Negative 2 plus 3, 1. Absolute value of 1 is 1. 1 subtract 4 is negative 3. Remember, this is our vertex. Okay, now let's find the y value of the vertex. Negative 3 plus 3, absolute value of that, subtract 4. Negative 3 plus 3 is 0. Absolute value of 0 is 0. Minus 4 is negative 4. Absolute value of negative 4 plus 3 minus 4. Negative 4 plus 3, oop, that gives us a negative 1. We got to take the absolute value of that. That's a positive 1. 1 minus 4 is negative 3. And then we'll do that same thing again. I'm going to erase the ones from up here and do that one more time for negative 5. Absolute value of negative 5 plus 3. Subtract 4, that's negative 2. The absolute value of negative 2 is 2. 2 minus 4 is negative 2. And then we're going to plot these on our graph. Negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, negative 3, negative 5, negative 2. And you can see that we get an absolute value, V shape, and we see the whole entire graph because we have our vertex and points on both sides of the vertex. So the vertex in this case is negative 3, negative 4, and yes, you have to identify these three things. These three things are three things that you will be identifying for every single absolute value equation. Domain, if we look at the domain, you can see that the domain is the x values. Look at the x values. We chose negative 1, negative 2, negative 3, negative 4, negative 5. But if you're looking at the graph, we could have chose 1, 2, 3, 4, 5, 6, and it's going to keep going forever and ever. I could have chosen any x value, positive or negative, and I would have gotten a value. So the domain of this graph is x such that x equals all reals. Okay, and now the range of this graph is the y values. Okay, so if I'm looking at the y values, I can see that my y values, this is the y-axis. If I look at the y values, it started at negative 4. This is negative 4 right there. And the y values went up from negative 4. If you want to look at the table, it went from negative 2 to negative 3 to negative 4, back up to negative 3, back up to negative 2, never going lower than negative 2 or negative 4. So the range is y such that y is greater than or equal to negative 4. Okay, and you can see that that's the y value of your vertex. That helps you. And the graph is going up from there, so it's greater than or equal to negative 4. All right, let's do another example. Y equals the absolute value of 2x plus 1, subtract 4. Again, we're looking for that vertex. So we're going to take the expression that's inside the absolute value and find out where that's equal to 0. Zero it out to find the vertex. Subtract 1. 2x equals negative 1, divide by 2, x equals negative 1/2. So my vertex is negative 1/2 something. I'm going to pick numbers on both sides of negative 1/2, like maybe negative 1, maybe negative 2, 0, and 1. And then I'm going to plug them in back into the equation and make sure that I get my complete table. So I'll have y equals absolute value negative 2, 2 times negative 2 there, sorry. 2 times negative 2 plus 1 absolute value, subtract 4. 2 times negative 2 is negative 4 plus 1 absolute value, negative 3. Absolute value is 3 minus 4 is negative 1. And I got to do that every single time. Absolute value 2 times negative 1 plus 1. Absolute value, subtract 4. 2 times negative 1 is negative 2 plus 1 is negative 1. The absolute value of negative 1 is 1. 1 subtract 4 is negative 3. Then I plug in a negative 1/2. 2 times negative 1/2 plus 1, subtract 4. 2 times negative 1/2 is negative 1. Plus 1 is 0. Absolute value of 0 is 0. 0 subtract 4 is negative 4. Okay, now we're going to plug in 0. 2 times 0 plus 1. Absolute value of that. 2 times 0 is 0 plus 1 is 1. Absolute value of 1 is 1. 1 minus 4 is negative 3. And then you probably already know what's going to happen with 1. 2 times 1 plus 1. Absolute value, subtract 4. 2 times 1 is 2 plus 1 is 3. And the absolute value of 3 is 3. And 3 minus 4 is negative 1. So yep, you were probably right. You see a pattern there. Okay, so now we're going to graph these. The vertex, we can write that down right away, is -1/2, comma 4, -4. That's our vertex. Hopefully we can see all sides of our V-shaped graph that we are looking for. So -1/2, -4. Okay, that's our vertex. -2, -1, -1, -3, 0, -3, and 1. Oops, scoot that over a little bit, I'm sorry. And then 1, -1. And so then there is our absolute value graph where you can see the vertex did help us get both sides of that V. Okay, domain. Domain of this graph will be y, oh, excuse me, y's are the range. I'm making lots of mistakes today, I'm sorry. X such that x is all real numbers. Again, this is the case for every absolute value function. I can plug in any value of x I want into my function and I will get a value, okay? And I can plug in negatives, I can plug in positives, and so I can plug any value I want in for x. So I can use any real number possible. The range, however, if you look at this graph, remember the range has to do with where this vertex is, and then the graph is going to continually go up forever that way, but it starts right here at -4, and then it continues on forever in the positive direction. So as you can see, the table goes from -1 to -3 to -4, but then back up to -3, back up to -1, and it doesn't get any smaller than -4. So the range is y such that y is greater than or equal to -4. Okay, one more and then we'll be done. We're going to do this one. Y equals negative absolute value of x minus 2 plus 3. Okay, again, we have to take what's inside the absolute value, set it equal to 0, get that x value of my vertex, put it in the middle of the table, and then we're going to find values of x on either side of 2, so that would be 3 and 4, 1 and 0, and then we're going to plug those values in to get our y values. So here we go, negative absolute value, 0 minus 2 plus 3. 0 minus 2 is -2. So negative absolute value of -2 plus 3. Absolute value of -2 is 2. Bring down that negative. Plus 3 is 1. Make sure that you don't distribute that negative. That's not what it means. Remember, order of operations, parentheses, or absolute value has to be done before we multiply by the negative outside. That's where a lot of people and students make mistakes. So make sure that you're paying attention to those negatives. -1, negative absolute value, 1 minus 2 absolute value signs. Kind of make your absolute value signs long enough so they don't look like an 11. Plus 3. So 1 minus 2 is -1. The absolute value of -1 is 1. Bring down the negative. -1 plus 3 is 2. Okay, let's do this again. Negative absolute value of 2 minus 2 plus 3. 2 minus 2 is 0. Absolute value of 0 is 0. 0 times any number is 0. So 0 plus 3 is 3. Now let's plug in 3. Negative absolute value, 3 minus 2, absolute value plus 3. 2 minus 1, or 3 minus 2 is 1. That's telling you the answer. Absolute value of 1 is 1. Bring down the negative. -1 plus 3 is 2. Now, you have probably seen the pattern, and so you probably already know what the y value for 4 is, but let's do it here just to make sure that you can plug it in. Negative absolute value, 4 minus 2 plus 3. 4 minus 2 is 2. The absolute value of 2 is 2. Bring down the negative. Keep bringing down the negative. Negative 2 plus 3 is 1. Yep, you were probably right. It is 1. Okay, now let's graph this. 0, 1, 1, 2, 2, 3, 3, 2, and 4, 1. Oh man, now this is still a V shape, but it's upside down. That's okay. You can probably tell, some of you, by looking at the equation, what is causing this to be upside down. As long as it's still a V and we have the vertex, and our vertex is 2, 3 in this case, we do still call this an absolute value graph. So now we have to talk about domain. What's the domain? Yep, always x such that x equals all reals. Always for absolute value. Okay, and then the range. What's the range? The range is y such that y. Now, when we look at our y values, see, this would be the y values, okay? See how it's touching the 3 and then going down, okay? Right here, there's the 3. That's the vertex. So we're not going to say greater than or equal to 3. We're going to say less than or equal to 3 because the graph is going upside down. Okay, so that is all I have for you today, and hopefully you have all of the examples written down, and we'll see you tomorrow in class.